Good day, grade 12s. I'm Mr. Masunda, and I'm going to teach you guys mathematics. And the topic that we are going to look at today is the hyperbolic function. So now let us go through the lesson outcomes. Now, by the end of this lesson, you should be able to do the following. You should know the effect of the parameters A, Q, and P on the graphs of the functions that are defined by the equation y equal f of x. It can be g of x, h of x, a over x plus p plus q. You should also, by the end of this lesson, be able to determine the equation of the hyperbola given a graph. All right, so now let us look at the effects of A, P, and Q on the graph of y equal a over x plus p plus q. Now, in the equation y equal a over x plus p plus q, the value of a affects the shape of the graph. So for us to know the type of shape that we are going to have in our graph, that is going to be determined by the value of a in our equation. Now, if a is greater than 0, in other words, a is positive, then the graph is going to be decreasing. Now, you'll remember from grade 10 that when you had a mother graph, now you remember your mother graph was given by y equal 1 over x, and then your a is positive, your a is positive 1 there. So we are saying that we are going to have a decreasing function. Now you will have your decreasing function is going to be on the first and the third quadrant. But these quadrants are with respect to your asymptote, because on your mother graph, you'll remember, you're supposed to have Q there, you're supposed to have P there. But in this case, your P, you're supposed to have P and Q. So in this case, your P is 0 and your Q was equal to 0, meaning that your asymptote are right on the x-axis. So we are saying, with respect to the asymptote, when a is greater than 0, your graph is going to be on the first quadrant and the third quadrant. And we say that your graph is it's a decreasing function. Now, if a is less than 0, then you are going to have an increasing function. Now, if we have an increasing function, if we have to go back on the blackboard, so again for your mother graph, so that is your y and that is your x, and your asymptote again are going to be on the x-axis, on top of the x and the y-axis. So now, if a is less than 0, you have an increasing function. And you will have your increasing function on the second quadrant and the fourth quadrant with respect to your asymptote. So your increasing function is going to look something like that. All right, so that is what you were able to do in grade 10. So what we are saying is that A affects the shape of your graph. A affects the shape of your graph. Now, if A is greater than 0, then you have a decreasing function. And if A is less than 0, we are going to have an increasing function. So that is very important. The parameter A will give you the type of function that we are going to have, whether it's going to be an increasing function or a decreasing function. Now, let us look at the other parameters. Now, the value of P on your equation, that will affect the horizontal shift of the graph. So this will tell you whether you should shift your graph to the left or to the right. It also gives you the position of the vertical asymptote. So from the value of P, you are going to get the position of your vertical asymptote. So if we were to look at the graph, the mother graph, we said our mother graph, let's say it's for an increasing function, so we'll have it like that. So it means that if now you have the parameter P, it is going to tell us whether we are going to move the graph either to the left, to the right, or we move the graph to the left. So every point will be moved to the left or to the right on that particular graph. That is the effect that the parameter P will have on your graph. Now, if P is positive, then you are going to translate. So there's going to be a translation on your graph which is horizontally P units to the right. So if your P is positive, it means that you are going to move your graph to the left. All right? Also, if P is negative, it's a translation that you are going to do on your mother graph, and this translation is going to be horizontally P units to the right. So if we are having this as our mother graph, all right, and P is positive, so we are saying that your graph should be moved to the left. So it means that if I were to redraw this graph, now with P not being equal to 0, with P being positive, so you'll remember your asymptote initially was right here on the x-axis, on the y-axis. So if you're going to move your graph to the right, you're going to move your graph to the left. So this asymptote will also shift as well. All right? So the asymptote will shift from the y-axis to the left. And then your graph will also shift as well. So your graph will look something like that. So there's a shift of your graph to the left because your P is positive. Now, if your P was negative, your asymptote will move from the y-axis, and it will move to the right, and your graph will also move to the right as well. So if I were to get a different color to show you the shift to the right, so the shift to the right would be something like that. So that is basically the shift that you will get on your graph if ever your P was positive or your P is negative. All right, so let us look at the other parameters. Oh, also, before we move to the other parameters, the vertical asymptote is given by the equation x equal negative P. So because when P was equal to 0, we said that the asymptote was right on the axis. Now, if P is no longer 0, now we are going to get a different position of this asymptote, right? So now, the equation of the asymptote, you get it by saying x equal negative P. So this is very important. If you want to know what the equation of the asymptote is, you just say x equal to negative P, and from your equation, you will know what that value of P is. And then you substitute it into this equation, you will get your asymptote of your graph. All right? Let's move on to the next parameter, which is Q. Now, if we look at the effect of Q, now the effect of Q is the vertical shifting of your graph. So it means that your graph is either going to be moving up or down. So when you see Q on the equation, you should know that it affects the vertical shifting of the graph, so you can move your graph up or down. Now, this Q also gives the position of the horizontal asymptote. So from the value of Q, we can also get the position of the horizontal asymptote. Now, let us look at what happens when P is positive. So if P is positive, we are going to translate the graph vertically Q units up. All right, so now, if we use the mother graph again, okay, let me just change that color. If we use the mother graph, y equal 1 over x. So now, let's say we have a Q there. So we are saying our mother graph, since our A is positive, so we're saying it's an increasing function, like that. It's a decreasing function, actually. So Let me just erase that part because our A is positive. All right, so we'll have a decreasing function like that. So now, what we then need to do is this graph must be shifted Q units upwards. Okay, so it means your vertical asymptote, your horizontal asymptote was right on the x-axis. So when you shift it, that asymptote is going to move up. So when it moves up, it means now your graph is going to be in that quadrant and it's going to be on that quadrant. All right. So now that is basically what happens when you translate the graph vertically Q units upwards. All right. So now, if Q is negative, we are going to translate the graph vertically Q units down. All right. So now, we get a different color. Again, originally, your asymptote was right on the x-axis. So if Q is negative, you are going to shift your graph downwards, meaning that the asymptote also shifts downwards. All right? So now your graph is going to be increasing, decreasing, so it's going to be like that, and it's going to be like that. So you can see that your graph has moved vertically downwards. In red there, you have your graph having moved vertically upwards. So those are the effects that Q has on your graph. So if Q is positive, you are going to shift your graph Q units upwards. Now if Q is negative, your graph must be shifted Q units downwards. All right, so also, we said that Q will give us the position of the horizontal asymptote. And the equation of the horizontal asymptote is given by y equal Q. So if we know the value of Q, we can just say y equal that particular value of Q will give us the equation of the horizontal asymptote. Now, very important, when they ask you for the equation of the horizontal asymptote or the vertical asymptote, do not just write, let's say for instance, P was equal to 2 and your Q was equal to 1. Do not just write 1 or just write 2. You should write y equal to 2. You should write x equal to something because this is an equation. So you should write it as an equation. So that is very important. All right, so now, also what is important is the axis of symmetry. So the axis of symmetry have the equation that is given in the form y equal, in bracket, x plus p plus q. And where do we get this x plus p plus q? We get it from that part of the equation. So if you just look at that part of the equation, you can be able to get the equation of the axis of symmetry. So if you are given an equation, you can just take your denominator, you put it in bracket, you add your q, and that will give you an equation. This will be the equation of the axis of symmetry with the positive gradient. Okay, so positive gradient, which is your m. Or for negative gradient, you will have an axis of symmetry that is going to be negative, in bracket, x plus p plus q. This is still coming from that, but this time, outside the bracket, you are going to put a negative sign so that you can be able to get the equation of the axis of symmetry for the negative gradient. All right, so these are two ways in which you can get the equations of the axis of symmetry. Alternatively, there is another method in which you can get the equation of the axis of symmetry. You could say y equal x plus c. This is for positive gradient, and y equal negative x plus c for negative gradient. Now, in this case, in order for you to get the value of c, you are going to make use of the intersection of your asymptotes. Where your asymptote intersect, that is the point that we are going to use. Say, for instance, you had a graph like the one that I'm going to give you on the board. Say, for instance, we have an asymptote. We are saying that is at 2, and then that is at 3. So where the two asymptotes meet, that point is what is going to be 2 is to 3. Now, your axis of symmetry are both going to pass through this point. The one with the positive gradient and the one with the negative gradient is going to pass through this point. So in order for you to get your C in the equation x plus c, y equal negative x plus c, you are then going to substitute this point onto the equation. So say, for instance, if you are looking at this point, to get your C, you are going to then say, okay, my y is 3 and my x is 2. So you're going to say 3 equal negative 2 plus c, and therefore your c will be equal to 5. So that is basically what you do in order to solve for the equation of the axis of symmetry if we are using this method. So we are basically saying there are two ways in which you can do it. You can get it from the equation, where you are just going to use the denominator on your equation plus your q, and then that will give you the equation of symmetry. Or you could use the form y equal x plus c and y equal negative x plus c. All right, so that is basically the basic concept that you need to get in order for us to sketch a hyperbolic function. If you want to sketch a hyperbolic function, those are the things that you need to know. You need to know the effect of A. So A, we say, determines the shape of the graph. You need to know about the effect of P, which is the horizontal shifting of your graph. You need to know the effect of Q, which is the vertical shifting of your graph. Once you know that, you can also be able to get the axis of symmetry. And then from the axis of symmetry, there are two types of axis of symmetries, one with a positive gradient, the other one with a negative gradient. And I've shown you both ways in which you can be able to get those. So now let us look at an example where we are required to sketch the graph of y equal 2 over x minus 2. All right, so now if we to analyze this question, let us analyze this question. So our A equal 2, so what does that mean in terms of our shape? Okay, so A is positive, so we know that we are going to have a decreasing function. So we're going to have a graph that looks something like that. All right, so we also know our Q. Q is negative 2. All right, so it means that our our horizontal asymptote is going to be what? Y equal Q, and our Q is negative 2, so Y equal negative 2 will be our horizontal asymptote. Now, if we look at our denominator, we are having x. So it basically means that P, in this case, our P is what? Is 0, because we do not have it. So it means our vertical asymptote is going to be what? X equal 0. So that is basically what we are having there. So that is what you can get already from your equation. So if you can be able to get those, you know the type of shape that you are having, you know your vertical asymptote, you know the horizontal asymptote, you should be able to plot this graph. All right, so now let us look at the worked out solutions. Now, if we look at our solution, we're saying that because A is positive, we have a decreasing function, and we know that the graph is going to be on the first and the third quadrant with respect to our asymptotes. Okay, now for x-intercept, we are going to put y equal to 0, and then we solve for x. So we're going to put y equal to 0 there, and then we solve for the x. So that is what we have. Our y is equal to 0. Now, if we take, we add positive 2 rather on both sides, this will be 2 equal 2 over x. And then we cross multiply, we'll have 2x equal 2. And then our x will be equal to 1. So we know the x coordinate at the at the x-intercept is going to be 1. So now it means that the x-intercept is going to be the point 1 is to 0. All right? So now we have our x-intercept, which is the point 1 is to 0. So now let us look at the y-intercept. Now, if we go back to our equation is y equal, I think that was 2 over x minus 2. Now, if we come back to this equation, and to calculate the y-intercept, we are saying you need to let x be equal to 0. Right? So if x is equal to 0, then we are going to be dividing by 0. And dividing by 0 is what gives us something that is undefined. All right? So it means that we are not going to have a y-intercept. So therefore, we are not going to get a y-intercept, because if our x equal to 0, our y is going to be undefined, and for that reason, there isn't going to be a y-intercept. All right, now in terms of the asymptotes, now our asymptotes are as follows. We have y equal to negative 2, since we can clearly see from the equation that our q is negative 2. And our vertical asymptote is x equal to 0, since it's clear from our equation that p was equal to 0. Okay, so now we also need the domain of the graph if we're going to sketch the graph. So the domain of a parabola, of a hyperbola rather, is going to be x, an element of all real numbers, excluding the point where you have the asymptote. Okay, and then where do we have the asymptote? We have the asymptote at x equal to 0. So it means our domain is going to be x, an element of all real numbers, but x should not be equal to 0. Now let us look at our range. Our range is going to be y, an element of all real numbers, except where you have the horizontal asymptote. And where do we have the horizontal asymptote? We have it where y is equal to negative 2. So it means that our range will be y, an element of all real numbers, but y should not be equal to negative 2. Okay, so let us look at the axis of symmetry. So from our equation, we said that the equation is y equal 2 over x minus 2. Okay, so I told you that this part will give us the axis of symmetry. Okay, so we are going to say y equal, this is x plus p plus q. Okay, so y will be equal to x, but our p is what? Our p is 0. Okay, and then our q is negative 2. So this will be one of our axis of symmetry, the one with a positive gradient. Now the one with a negative gradient, this will be y equal negative x plus p plus q. Okay, so but then again, we said that our p is 0 and our q is negative 2. So this will become negative x, negative 2. So these are our two equations of axis of symmetry. Now, if we wanted to use the other method, we would say, okay, what are our asymptotes? Our asymptote, we have a vertical asymptote that is x equal to 0, and a horizontal asymptote which is y equal negative 2. So where do these two meet? They meet at the point 2 is to 0 is to negative 2. So we said we have y equal x plus c. So to get the value of c, we are going to make use of that particular point. So we substitute that will be negative Negative 2 equal 0 plus c. So you can clearly see that c is negative 2. So for the positive gradient, we'll have x minus 2. You can do the same for the negative gradient, and we are still going to get that very same equation. Okay, so there we have all the things that we need in order for us to plot this graph. Now we can sketch the graph and see what it looks like. Okay, so there is our graph. You can clearly see. Okay, so I just need to add arrows there. They are not there because of the limitation of the software that we use to do this. So there should be arrows there, so we can clearly see that this is our horizontal asymptote, which is at y equal negative 2. And here is our vertical asymptote. This is at x equal to 0, which is the same as the y-axis. Okay, I've also plotted for you the axis of symmetry. This is the one with the negative gradient, and that is the one with the positive gradient. So that is basically what our graph looks like. And that's our shape. We said that because A is it's positive, our graph is going to be on the first quadrant and the third quadrant with respect to our asymptotes. Okay, so now in order for you to get a good shape, you can get an extra 2 points or so that your shape can look well. So I have another shape, a point there and another point there, so that I can have a beautiful shape for the graph. All right, so that is the first example. Let us go to the second example. We are asked to sketch the graph of y equal g of x equal negative 2 over x plus 1 plus 1. Now they want us to clearly indicate any intercepts with the axis, the equations of asymptotes, and the equations of the axis of symmetry. All right, so now if we analyze our graph, our equation rather, if we analyze our equation, we can clearly see from our equation that our A is less than 0 because A is negative 2. So what does it mean? It means increasing function. Okay, and it also means that our graph is going to be on the second quadrant and the third quadrant. We can clearly see that our Q is 1, so our axis, our asymptote, the horizontal asymptote will be y equal 1. And then we can clearly see that our P is equal to 1. So, but we know the equation of the vertical asymptote is given by x equal negative P. So we substitute P there, we'll have x equal negative 1. Okay, so those are the things that we can be able to get from just the equation. All right, so now let us look at the worked out solutions that we're having. So we say that A is less than 0, so it's an increasing function. Okay, so for y-intercept, we are going to set y equal to 0. So if we set y equal to 0, we solve for x. So that is 0. We take this to the other side, it becomes negative 1. We cross multiply there, so this multiply by that multiply by that, we are going to get negative x minus 1 equal to negative 2. We solve for x, we get x equal to 1. All right, so it means that our x-intercept is going to be at the point 1 is to 0. Okay, let us look at our y-intercept. So to get our y-intercept, we set x be equal to 0. So on our equation, we are going to say x should be equal to 0. So we've replaced our x with 0 there. So y will be equal to negative 2 over 0 plus 1, and we get y equal to negative 1. So this tells us that our y-intercept is going to be the point 0 is to negative 1. All right? So in terms of our asymptote, we've already I've already explained that from just looking at the equation, that our horizontal asymptote will be y equal to 1, since we can clearly see that q is equal to 1 from the equation. And we said that our vertical asymptote will be x equal to negative 1, since x equal to negative p, and we can clearly see that p equal to 1. Okay, in terms of the axis of symmetry, our axis of symmetry, we can get it from the equation. We say that this is going to be y equal to x plus 1, and this will give us y equal to x plus 2. So this is the axis of symmetry with a positive gradient. Now the one with a negative gradient will say y equal negative in bracket x plus 1 plus close bracket plus 1. We remove the bracket, we'll have negative x, negative 1 plus 1. This is negative x. So it means that the axis of symmetry with a negative gradient, it's y equal to negative x. All right, in our domain, it's going to be x an element of all real numbers, except where we have our vertical asymptote. So it means that x should not be equal to negative 1. And our range will be y an element of all real numbers, except where you have the horizontal asymptote, meaning that y should not be equal to 1. So that is in essence all the important details that we need in order for us to plot our graph. We have our intercepts, we have our x-intercept, our y-intercept. We know our asymptotes, so the vertical and the horizontal asymptote. So we have our axis of symmetries, and we know the shape of the graph. We know that we are dealing with an increasing function. So now we can plot our graph. Let us look at what our graph looks like. So that is our graph. So our graph, as we saw from the sketch, so since these are our asymptotes, we can clearly see that our graph is on the second quadrant and the fourth quadrant with respect to our asymptotes. So there is our axis of symmetry, y equal negative x, and that one is our other axis of symmetry given by the equation y equal x plus 2. Now, very important, you should also indicate on your graph the equation of the axis of symmetry and the equations of the asymptote. So for our vertical asymptote, which is that one, I've indicated that that is x equal to negative 2, so it cuts the axis at x equal to negative 2. I also did the same for our vertical asymptote, which is that one, to say that this is the equation, it's y equal to 1. So you need to indicate all those things in your graph, except in cases where they've actually told you what you need to put in your graph. So it's very important that you consider the question as to what is it that they want you to show in your graph. All right. So now, let us now look at determining the equation of a hyperbola. Now, the equation of a hyperbola is of the form y equal a over x plus p plus q, as we've already stated. However, these are not the only forms that this equation, this hyperbola can be found. All right, so this is just the general equation. The other forms can be something like y equal ax plus, let's say, b over x plus p. So you can find the hyperbola being given in this form, or you can find it being given in the form y minus, let's say, b, and then x minus c equal a. So these are other forms in which the hyperbola can be given. But it's very important that you know that as much as there are other forms in which it can be given, which are these other two, this right here is the general equation of the hyperbola. So now we are saying this is the general equation of the hyperbola. So if you want to determine the equation of the hyperbola, the first thing that we are going to do is to determine the equation of the asymptotes. So once you can be able to determine the equations of the asymptotes, then it means that you would have determined the values of P and Q. So then you can substitute your Q and you can substitute your P on that equation. So it means that the only thing that you are remaining with will be to determine the value of A. And how do we determine the value of A? We are going to substitute the coordinates of a point that is on the graph into this equation. And then you can be able to determine the value of A. So that is, in essence, what you are going to be doing when you determine the equation of a hyperbola. Sometimes when they ask you to determine the equation of the hyperbola, they will give you the value of A. And then from the graph, you can either be able to get the value of P or the value of Q. So if you cannot get one of them from the graph, it means that you'll have to calculate it the way you would calculate A if it was not given. So that is a case where they've actually given you A, but they don't give you one of the asymptotes. All right, so now let us look at an example. Now this is example 3. They want us to determine the equation of the following hyperbola, where the equation is, the general equation is given by A over x plus P plus Q, and then they give us the vertical asymptote, which is x equal to -2, and then the horizontal asymptote, which is y equal to 1. And the graph passes through the point 4:3. So from just the given information, before we even look at the graph, we can clearly see that you are given the value of Q. So from this, we can see that the value of Q is what? It's 1, because from the horizontal asymptote, we know that the horizontal asymptote is given by y equal Q. So here they are saying y equal to 1, so it means that we should know what the value of Q is. The value of Q is 1. Also, we are given the vertical asymptote x equal to 2, so we can use this fact to be able to determine what the value of P is. So be very careful. P is not equal to 2 in this case. Remember, the vertical asymptote is given as x equal -P. All right, so that is very, very important, something that you need to remember. Okay, so we can clearly see we have the asymptotes and a point, so we'll need to find what the value of A is when we do our calculation. So this is basically the graph that we are given. So we know these asymptotes are given to us, and we are going to make use of that point to determine the value of A. All right, so now let's look at the solution. Now the vertical asymptote, as we said, is x equal to 2. So if x equal to 2, we should remember that generally the vertical asymptote is given by x equal -P. So, but we know that, okay, it's in general, that is x equal to -P, but we know our x is what? It's 2, all right? So we can be able to solve for P. So if we divide by -1 there, we can clearly see that our P is going to be equal to -2. All right, we are also given the horizontal asymptote, which is y equal Q, y equal to 1, but generally we know that y is equal to Q. So if our y is equal to 1, therefore it means that our Q will be equal to 1. So we can therefore conclude that for now, the equation can be given as y equal to A over x minus 2 plus 1, because we know the value of P and we know the value of Q. So what remains is for us to find the value of A. Okay, so now let us look at what we are going to do to find the value of A. To find the value of A, we're going to substitute the point that was given on the graph, which is 4:3, into that equation. All right, so we substitute, in place of y, we substitute 3, and in place of x, we substitute 4. And then we are going to solve for x, for A, which is our unknown in that equation. So if we simplify this denominator there, we have 4 minus 2, so that becomes 2. All right, we can take this to the other side. It becomes negative. So that becomes 3 minus 1, which is 2. And then we are left with a over 2 on the other side. We cross multiply. We find that the value of a is equal to 4. All right, so it therefore means that our equation is going to be given by y equal to 4 over x minus 2 plus 1. So that is how easy it is to actually find the equation of a hyperbola. All you need to do is to identify your vertical and the horizontal asymptote, and those will give you the values of p and q. Now, once you have those, you can use any point that is on your graph, and then you substitute into the equation to be able to find the value of a. So that is basically what we did. So now let us look at an exercise. Now, in this exercise, we are told that a sketch of a hyperbola in the form d f of x equal d minus x over x minus p, where p and d are constants, is given. The dotted lines are asymptotes. Now, the point A, which is 5:0, is given on the graph. So that is basically what we are having there. So if we can analyze the graph that we are having there, so we are given the vertical asymptote, which is that one, and we can clearly see that it's passing through the point x equal to 2. So that should tell us something about the value of p, because from this we can clearly see what the vertical asymptote is. So we should be able to know what p is, okay, by just making use of that. And then we can use this point to then be able to find the value of d. Now let us look at the worked out solutions, or rather, let's look at the question. The first question, they want us to determine the value of p and q, okay? So we can already be able to determine the value of p, and using the other point that is on the graph, I said that we can be able to get the value of d. The second question, they want us to show that the equation can be given as y equal 3 over x minus 2 minus 1. So we clearly saw in this equation that the equation here is not given in this general form. It's on the other form that I spoke about. So we should be able to move from this form to the general form of the parabola. So that is what we are going to be doing as well. And then the last question, they say we need to write the image of A if A is reflected about the axis of symmetry given by the equation y equal x minus 3. So we're going to do a little bit of a transformation here, which is a reflection about that point. Okay, so now let us look at how we determine the values of d and p. Okay, so we said that we are given the vertical asymptote, which is x equal to 2. So from this, we can be able to get the value of p by saying, but we know the general form of the vertical asymptote. It's x equal to negative p, and our x is equal to 2. So it means that we can get our p to be equal to negative 2. All right, so now what is left is for us to find d. Now to find d, we are going to substitute the other point that is on the graph. Okay, the other point was what? 5:0. So our y is 0, so we replace y with 0, and we replace 5 with 0 there. So if we simplify our denominator there, we can clearly see that that is going to be 5 minus 2 is going to be 2. And then we cross multiply, we'll have 2 times 0, which is 0. And then on the right-hand side, we're going to be left with d minus 5. And from this, we can clearly see that d is equal to 5. So what does that then mean? It means that once we know, because now we know the values of d and the values of p, we have our equation. Okay, but our equation is not in terms of the general form that we know of the hyperbole. Hence, the next question that says that we need to show that the equation that we've just determined can be expressed as y equal 3 over x minus 2 minus 1. All right, so this is the equation that we determined. We got the value of d, we got the value of p. So that is the equation of our hyperbola as it stands. Now they want us to write this equation in that form. So it's very easy to work with these questions. Now what we are going to make use of here, we are going to make use of the identity element of addition. So this is very important. This is where you need to apply your knowledge in mathematics. We are going to make use of the identity element of addition, and that is 0. Okay, so we are basically going to add 0 on that equation. And this 0 can be anything that we want it to be. Okay, we add 0, we just change the way the equation looks, but we do not change the equation itself. So that is the trick that we are going to use in order to move from one form to another. Use the identity element of addition, which is 0. So I'm going to add 0 on that equation. And let us see at what that 0 is. So if you can see, I've added 2 and positive 2 and negative 2. So plus 2 minus 2. So that's basically 0 there. Okay, so it means that what I'm having here in terms of value, it's no different to what I started off with, because what I've added is 0. 2, positive 2 minus 2 is 0. So I've basically added that to change the outlook of my equation, but I did not change the value of the equation. But how did I come up with this 2? How did I know that I needed to add 2 there? So that will be determined by what your denominator is. Okay, so if in your denominator, in place of p there, you have negative 2. So it means that your 0 that you are going to add will be positive 2 minus 2. If that was 3, I will then add plus 3 minus 3. Okay, so that will be my 0. So it's going to be determined by what I'm having in the denominator there. So now, once I've done that, I'm going to group these numbers that I'm having here. So I take this negative 2, I group it with the 5 there, and I take this negative x and the 2, I group them. Okay, once I've grouped these ones, I factorize negative x. I factor out negative 1. If I factor out negative 1, there I'm going to be left with x minus 2, which looks the same as what I'm having in the denominator there. All right, so now if I simplify, I had 5 minus 2, so that gives me 3. And here I have negative in bracket x minus 2. I can separate my numerator. Okay, by separating my numerator, I can then say this is what 3 over x minus 2 minus x minus 2 all over x minus 2. So these I can divide and they give me negative 1. So it then means that my equation can be given as y equal to 3 over x minus 2 minus 1, which is basically what they wanted us to show. All right, so there is another method as well, which is a more convenient one, more especially when now the coefficient of x there on the numerator, it's not negative 1 or positive 1. If, say, it's 2 or 3, then this method becomes a little bit tricky. So, but the method that I'm going to show you now also works when you are having a situation such as that one. So this is where you're going to use the long division method. Okay, so you guys are familiar with the long division method. So your denominator will become your divisor, so you'll have that. And then you'll have negative x plus the 5 that you had as your numerator. I've just swapped these two around. This is still the same as 5 minus x. All right? So now I'm going to use the long division method. I'll say this x divided by that x, I'm going to get negative 1. I'll say this negative 1 times this x, I'm going to get negative x. This negative 1 times that negative 2, I'll get positive 2. All right, so I'll divide. I'm going to subtract. I'll say negative x minus x. So this becomes 0. And then I'll have 5 minus 2. This gives me 3. Okay, so now, on these workings that I've done, I want to show you something. This, on the general form, it's your denominator. This right here, which is your quotient, it's your Q. That remainder there is going to be your A. So we know the general form is given in the form A over X plus P plus Q. So from this, what I've just done, I have my Q, I have my A, and I have that as my denominator. So it means I can therefore say y equal 3 over x minus 2 minus 1, which is exactly what we were asked to show. So when you deal with this type of questions, you have options that we can use. You can either use the long division method, or you make use of the form that requires you to make use of the identity element of addition and subtraction, which is 0. All right, but I would like to think that you guys are preferring to use the long division method because it looks much simpler and much quicker to get to your solution. All right, so now let us continue with our questions. So the next question now, they want us to write down the image of A if A is reflected about the axis of symmetry, y equal to x minus 3. Okay, now this question is a bit tricky. All right, because it's a bit tricky because you guys can do reflection about the line y equal to x, but you cannot do reflection about the line y equal to x minus 3. All right, so that's what basically makes this question to be a bit tricky. But let us look at how we are going to do this question. So I'm just trying to recreate the graph that we had. So we know this is what? This is 2, and this is negative 1. This is y equal to negative 1. That is x equal to 2. So now they want us to reflect this point, okay, about the line, the axis of symmetry. Remember we said this axis of symmetry passes through the point where the asymptote meet, okay? So now, since the equation is y equal x minus 3, so we know that that point there, the x-intercept, if you let y equal to 0, and you solve for x, you find that x equal to 3. So that is your x-intercept, which is 3 is to 0. The y-intercept, if you let that be equal to 0, so you find that your y-intercept is going to be negative 3. So it tells me that this point here is negative 3. Okay, but what I'm saying is that the transformation that we can be able to do right now is the reflection about the line y equal to x. So that is what I want us to make use of to solve this question. So now, if you do a reflection about the line y equal to x, these two lines are parallel because the gradients are the same. So you can say what happened to this point, to this line to get that line. If you look at the x-intercept here, it's the point 0 is to 0. The y-intercept is also 0 is to 0. Now, on the new graph, y equal to negative 3, our x-intercept is 3 is to 0, and our y-intercept is 0 is to negative 3. So it means that the x-intercept of the line y equal to x has been translated. It was translated to the right how many units? 3 units. So if you translate it to the right 3 units, you get there. And if you translate this one vertically downwards for 3 units, you are going to get that point there. And then if you draw it, you are going to get the line y equal to x minus 3. So this line, you can get it by translating that line. So I'm going to make use of this point to reflect that, and then do a translation on the point to get the point that you will get by reflecting about this point. So if I reflect this point about the line y equal to x, these two are just going to swap, so the point becomes 0:5. So my point will be somewhere there, which is 0:5, okay? But now, because I did not reflect it about this line, I reflected it about the line y equal to x, I must do the translation now on this point. And what is my translation? The x point must be translated 3 units to the right, and the y point must be translated 3 units downwards. So if I translate this point 3 units to the right, my x becomes what? Becomes 3. And if I translate the point, the coordinate 5, 3 units to the downwards, that point becomes 2. So that will be the image of A reflected about the line y equal to -x. I understand this was a bit of a trick question, so you needed to be smart about how you go about doing this question. So if you look at now what is the solution, we're saying that the image of A reflected about the axis of symmetry y equal x minus 3 will be 3:2. And that is basically all we have for today. Thank you very much for being with me. And I would like to believe that you guys are practicing. Practice, 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 practice. You will get this right. And a bit of an advice, whether you are studying physical sciences, whether you are doing your home languages, in between your break, take a question on algebra, do it, and you shall be fine. Thank you.